Dear students, in my previous lecture we were discussing about the bookworks or derivations of Laplace transform of derivatives. Laplace transform of first order derivative, Laplace transform of second order derivative, and so on. These derivatives you will come across in the form of a differential equations, where differential equations are nothing but arise as application problems. Fine. We have discussed about the first order derivative using Laplace transform definition. As a result, this L of f dash t, here f dash t is only the standard representation for all the situations what we take. Some situations will be explaining that is y in terms of t, because t is a time period and it will be acting as an independent variable. In place of this f dash of t, most of the times we will use y dash of t, or most of the times we will use x dash of t, like that. So, the symbol which represents f, y or x, all these symbols will represent as functional representations and their derivatives which we have to discuss through Laplace transform. Okay. Already I have mentioned for what purpose this Laplace transform of derivatives we have to study, because differential equations do arise in various forms in the engineering problems, not only engineering problems, in various fields. For example, in the civil engineering branch, the bending of a beam, which we have to calculate the deflection of that particular beam when the load is going to lay over the beam. Whether that load which is applied in the form of uniform distribution or non-uniform distribution of that particular beam. Then the corresponding differential equation which we have to explain in the form of first order, second order, third order, depending on the number of times the slopes which the terms are going to represent in the differential equation. Then suppose that differential equation is going to be solved, or it is possible, solution is possible, that differential equation solution is possible through ordinary methods. Starting from the two elementary methods, we call them as analytical techniques. If those analytical techniques are going to support the solution for all these linear and with the constant coefficients, if they are going to support, then we can make use of the initial conditions and then we can write the solution. If those analytical methods will not support our solution of differential equations, then we have to switch over to some other technique. Among some other techniques, we have up to this level of syllabus, we have Laplace transform technique. So, this is preamble once again which we are going to derive these formulas. In my previous class, we have derived two results, that is L of f dash of t, this is the result we have derived in the previous class, and the next one, that is L of f double dash of t. Here double dash is missing, that is L of f double dash t, that is equal to, that is here that double dash is not there, s square into L of f t minus s into that is s to the power 1 into f of 0 and so on. So, these terms, there are some printing mistakes here, but the second order derivative will be taking in the same fashion, that is L of f dash of t, that is equal to s into L of f t minus f of 0, and that is equal to L of f t. Most of the times we consider its functional value as s, because it is the basic definition of Laplace transform. Even in the electric circuits also, the differential equations which we come across as first order and second order, even in the signals and systems also we come across the differential equations as first order, second order, like that. And more commonly we use in fluid mechanics in civil engineering, fluid mechanics in mechanical engineering, and thermodynamics in mechanical engineering, even in the case of chemical engineering. Likewise, differential equations in varieties of forms we come across. It is the very important task when those differential equations, presently we are solving, you must remember that presently we are studying these differential equations which are represented by function of single independent variable restriction. It is not that more than one independent variable, because you know that more than one independent variable we call them as partial differential equations. So, we deal with only the ordinary differential equations, and they can be solved by Laplace transform method. So, we have the definition of Laplace transform, that is 0 to infinity e to the power minus est f of dt f of t dt is equal to f of s. Yesterday we derived the first result, that means L of f dash of t is equal to s into L of f t minus f of 0. This is first result. Second result also we derived yesterday in the previous class, that is L of f double dash of t is equal to s square L of f t and minus s into L of f t minus f of 0. Till this step in the previous lecture we studied, and I shall continue for third order derivative, and we have to generalize it for nth order derivative. Today we shall study this continuation of these Laplace transform of derivatives. Let us start with the next derivation, that is L of f triple dash t. This is the third one. What happens? Therefore, once again we will use this definition, 0 to infinity e to the power minus st and f triple dash t, it is dt. Here you must remember that whatever this function is there, you have to replace under the integral sign. Here first order you have replaced first order and the result after the integration. Second order you have to replace, and after the integration this is the result. Now third order you have to replace under the integral sign. Now you have to continue integration process using product rule. That product rule will be, this is to be selected as second function in the product rule, and this is the first term. Once again you have to recall, that is integration of uv into dx is equal to u into integration v dx minus, that is integral of differential of first function into integral of second function, like this. That is integration by parts for one time. Now next time if you continue again one more time, you can continue the second term. If the limits are given, you have to apply. Here this is called indefinite integral, means integration without limits, but here with limits we have. After the integration is over, you have to replace t is equal to infinity and t is equal to 0. Let me start with this. First term into integral of second first function into integral of second function minus integral of differential of first function into integral of second function. So first function e to the power minus st into integral, that is f double dash t, this is with the limits 0 to infinity minus integral of differential of first function, that is minus s e to the power minus st, and then that is f double dash t, that is also integration with limits as 0 to plus t. Therefore, e to the power minus st, let me repeat this procedure, what that formula is there, I have applied it, and then as a result we are able to get these terms on the right side. That should be first function as it is, integration, already I told you in the previous lecture, differentiation derivative is there. To remove the derivative, you have to choose that function as second function. That should be through integration. Higher order derivatives will be reduced to the lower order. Therefore, higher order means third order, it is reduced to the second order. Higher order, third order, here also it is second order. Then your t is equal to infinity e to the power minus infinity. So that substitution becomes 0. And for the lower limit, e to the power t is equal to 0 means e to the power 0 is 1 and f double dash 0 minus, this minus becomes plus, and yes, you can take outside the integral sign, because s is constant when you are working the integration with respect to variable t. Therefore, e to the power minus st should be f dash of t, it is dt, minus f double dash 0, plus s into 0 to infinity e to the power minus st and f double dash of t. Therefore, minus f double dash 0 and plus s into, and this one can be written, once again we will make use of the definition of Laplace transform. When ft is there, we can write it as L of ft. When f double dash t is there, we can write the same thing under the flower brackets, inside the flower brackets, that should be as it is f double dash of t, because we take the advantage of the result what we derived as a second result. Already we have derived the Laplace transform of second order derivative. Second order derivative, there are 3 terms. We replace these 3 terms here and we will simplify. That means that substitution makes you completely reduced work. That means instead of continuing the integration, you can simply replace that and you can make use. What is that result? Minus f double dash 0 and plus s into, inside the bracket, all the 3 terms, because it is already done, L of f double dash t. Therefore, s square L of f t minus s into s square minus, this is L of f t, first term, but second term is s into f of 0 and f dash of 0. Make this correction please. Then s into f of 0 and minus of f dash of 0, because after the integration L of f t will become this value after substituting the limit, that I am making use. Now, when you take this s inside, that becomes minus f double dash 0 and plus s cube L of f t minus this outside s and one more s, that is s square and f of 0, that is f double dash 0 and f triple dash, that is here s is multiplied and becomes s square and one more s. This is s is multiplied with minus sign, minus of s into, it is f dash of 0. Now, in every result what we did is, this L of f t we have written as a first term because it is with plus sign. Likewise, we write here s cube L of f t and minus s square, it is f of 0 and minus of s into f dash of 0 and another term, last term is minus of f double dash 0. Listen carefully here, because if you understand these results, I am sure that this topic you can make more simpler when you are going to handle the application of these results to the problems. Now, that is s cube into L of f t minus s square f of 0 minus s into f dash of 0 minus f double dash of 0. Therefore, this is for the third order derivative, that is f triple dash of t, f triple dash of t. Then you can see the appearance of these coefficients for the Laplace transform and their functional values. In the first result, you have to understand s appears first, remember, and this is first order derivative, that means s to the power 1. If the derivative is there, what is the meaning of the order of derivative? All of you know that when you started learning differential equations, what is the differential equation, what is the order, what is the degree, okay, and what do you mean by linear? So, order of the derivative is the order of the highest order derivative appear in the differential equation, and the degree of the differential equation is the degree of the highest ordered derivative appear in the differential equation. So, now we are not bothered about the degree, but we are more concerned with the order of the derivative. So, order of the derivative means first order and s to the power 1 should be there, order of the derivative second and s to the power 2 should be there, and here you can assume this becomes s to the power 0 and this becomes s to the power 1 and this becomes s to the power 0. That means this is in the decreasing order. So, order of the derivative is 1, the first term should be multiplied by the same as degree, but s is s to the power 1 means you must call it as a degree, and f dash means you must call it as order of the derivative. And similarly, and this goes on taking the reduced power by 1 unit in every time, in every term. That is, here 1 is there, then you have to write it as 1 minus 1 is 0. The 0 you are getting like, that is 1 minus 1 equal to 0. That means s to the power 0 is equal to 1. That we are not writing because it is understood, all those coefficients are understood, so we are not going to write it. And only for understanding these details more perfectly, then in this way you can write the reduced powers of s. Here second order is there, second degree and first degree and 0, that means 2, 1, 0. In the decreasing degrees, that means by reducing every time by 1 unit. 2 minus 1, 1, 1 minus 1, 0, like that. So therefore third order derivative, here in the same fashion you can observe, that is third order derivative is there, and here third degree, that is s to the power 3. Then 3 minus 1 is 2, 2 minus 1 is 1, and 1 minus 1 is, that is s to the power 0. You can understand if you want, not needed in this last coefficient, it is understood because variable to the power 0 is 1, therefore it is nothing but s to the power 0. Only for your understanding purpose these things are necessary. Then remember, in all these three derivatives you have this order. Now I am going to generalize the result for nth order derivative, and once you understand these meanings of all these things, I am sure that applications problems you are going to deal with by applying whichever the order of derivative, highest order derivative in the given differential equation is going to be appeared. Accordingly you will use the expression, you don't integrate there, you don't use Laplace transform definition right from the beginning, that integral equation you don't use like that, but you will use the derived formulas, that means derived expressions, these expressions in the differential equation, and you will make use the initial conditions, and you can reduce to get the inverse Laplace transform. Then this is third order derivative, and similarly I don't derive the fourth order derivative, but directly I am going to write fourth order derivative and then I will generalize. Okay, that is fourth result, I can call it directly. I am going to write f fourth order derivative. I hope from your side I can expect this answer when you have understood all these things, because things are very clear. In every derivation, first term is L of ft multiplied by the degree which is equivalent to the order of the derivative, left side, okay, and then nowhere L of ft is there in the remaining terms, but s is going to be reduced by 1 unit. And another very important secrecy is there to remember the formulas, these things in your fingertips, is this. In the first one, minus of f of 0, remember there are three observations. One is the degree, and next one is except first term, in every derivation all the remaining terms will be multiplied by minus sign. Remember this. That is another important observation as a clue which you can remember. And first derivation means first order derivative, that is f of 0, second order derivative f of 0 and then f dash of 0. That means f is going to be increased by one order derivative. That means this is without derivative, this is first order. Now third order is there, that should be second order, like that. So degree is equal, but the order of the derivative for functional values, when you substitute t is equal to 0, then it will be one number less. That is f dash is there, here f to the power it is nothing but without 1. F double dash is there and f to the power 1 is there, that means one number less. And f third order derivative, and you have one number less is, that is for the last term as f double dash. If triple dash is there, you have to write it as double dash. These things must be in your fingertips. If you do not understand these things, I am sure that you cannot handle the differential. But see, mathematics is such a subject when that becomes easy when you make that subject as easy. That is an important secret slogan. If you, and you cannot read all these things like a novel. You have to reproduce, you have to give the work to your hand and then practice it 2-3 times. If you do not understand, then you must make a question, because mathematics subject is like that. You must make a question and you have to go for the reasoning of the things what we are explaining, and then only you can understand the procedure of deriving and procedure of solving the problems. Now directly you can write. I am sure that I can expect the answer from your side. What is the first term then? S to the power, how much I have to write? The answer is, that is third degree here, third order. The answer which I am expecting from your side is, it must be 4, s to the power of 4. So 1 is matching. Then L of f of t, first term is covered. Now the second term is, that is s to the power 4 is there, and if you observe the previous set of expressions, that is s square is there, and here minus, that is s to the power 3 and f of L of f t, then functional value, that is f of 0, second term. Then third term, in the same fashion you observe, it's one number less, that is s square, and f should be increased with derivative, like f dash of 0, and till where you are going to write s to the power 0, till that you go on writing, and obviously it will be ended with one number less the order of the derivative, whatever left side you are going to specify, that is s into f double dash 0 minus, that is f triple dash 0. Now you compare. There is nothing in this. Once if you understand all these things, I am sure that you can go for any order of derivative when you are applying Laplace transform. First order derivative 2 terms, second order derivative 3 terms, third order derivative 4 terms, and fourth order derivative 5 terms, 1, 2, 3, 4, 5 terms. And similarly, I am going to generalize as nth order derivative, because you do come across the problems of various orders of derivatives. Don't believe that only you are getting first order, only you are getting second order, because the wave propagations will be explained at different slopes, even trajectories also you are going to study. Then first location, the slope which you are going to expect, then your order of derivative is first order. Second order, that is derivative. That means when you are explaining the slope of the curve at the second location, then second order derivative you have to specify. Like that the application meaning comes for the differential equations. Now this is for fourth order derivative when you are applying Laplace transform, and for fifth order in the same fashion you can extend, but I am not going to write, but I am going for the very intelligent answer from your side that I am expecting for nth order derivative. What should be that? L of f to the power n of t should be in the same order. You must observe right side the terms which you are going to write. So now I think you can fix first term is what and last term is what. This is nth order derivative. According to this, this is third order, this is fourth order. Nth order means n minus 1th order of the derivative, last term, and the first term s to the power n should be there, so that you can easily write what should be the first term, that is s to the power n L of f t minus, that is s to the power n minus 1. This n, if you observe this order, n should be continuously reducing by 1 unit to every functional value. That means f of 0 minus s to the power n minus 2, that is f dash of 0 minus s to the power n minus 3 f double dash of 0, then minus in this type. In this way if you continue, then what should be the last term then? Easily you can identify here this one, here this one, here this one, and here is this. According to this, what I have to write? Then minus, it must be with minus, and then f to the power n minus 1, because n is there and one number, that is sorry, f to the power, that is n is there, and then n minus n, it is nothing but n minus n, sorry, derivative is n minus 1, but s to the power here, if you want to expect, that should be n minus n, s to the power n minus n. Last term will not be containing s, but last but one term should be containing s, and this is n minus of n and its previous term. This is last term. Last but one term should be s to the power n minus of n minus 1, like this it must be. Last but two terms should be s to the power n minus of n minus 2. Then this n cancels, you are getting minus into minus, that should be s square, and this n cancels, you are getting it as s to the power 1, but last term n minus n gives us s to the power 0. S to the power 0 is equal to 1. Therefore, we don't write, and in every expression last term should be s to the power 0. That is going to happen when you write as a stereotype of terms which you are going to arrange. Then n minus n should be the last term. As a result, s to the power n minus n is 0. Then that is the expression. Remember all these derivations. These are very important derivations. If you do not understand these things, and when you are going to apply these things in the case of solution of differential equations, and you will find more comfortable. Yes, before going to solve the problems or applications of these derivatives, you must know the inverse Laplace transform, because all that Laplace transform topics you have been studying in this bridge course, that is for 4th semester additional subject, all that syllabus in the Laplace transform you are going to study. So three things you are studying. One is direct Laplace transform, and next one is inverse Laplace transform, that is L inverse of Fs is equal to E of t. That is, in L of Ft is equal to F of S. If you write this L to the right side, you are getting L inverse. That is what this result. What all you have studied in direct Laplace transform, and in the case of inverse Laplace transform, same topics you have to write in the form of the statements given in terms of S. Then applying Laplace inverse, you must get in terms of t. Therefore, list of elementary Laplace transforms you have to recall before going to solve the problems. In this case, fine. What all those list of elementary Laplace transforms? Because I shall discuss the problems as the applications on this topic with every term on the right side, like constant, like exponential, like trigonometric, like the properties of Laplace transform which you are going to use as derivative property, then shifting property, and then integral property. All such terms will be there. Along with this, some other varieties of problems also you will find as applications. Among them, as one is partial fractions, and the next one is completing the square method. You must have studied in the 12th class syllabus in the basic integrations. Completing square method will be written for the terms which are in the form of quadratic, or in the form of third degree, or in the form of fourth degree. You have to arrange as factorization form, and then to each factor the differentiation. If you are studying, you are going to apply differentiation, and integration if you are going to study, then integration you will apply for each term. Yes, let me write a list of formulas before going to the actual problems. That is, first of all, this is f of t, right, and then f of s. I am sure that already you have studied. For this, L is applied, and as a result it gives us f of s. First one, for example, a, that means f of t is equal to a. L of a is equal to, that is a by s. That means a is equal to any number in the real number system. Then e to the power at, then 1 by s minus a, that is plus or minus, this becomes minus or plus. That is, in the reverse order you have to think. That means if f of s is given, you have to write this. If f of t is given, you have to write like this, because these two things will play the major role. Then sine of at, that is a divided by s square plus a square. This is a review of these basic elementary Laplace transforms, which you have to think in opposite direction, that is inverse Laplace transform of certain functions. Then sin of at gives a divided by s square plus a square, and then cos of at gives, that is s divided by s square plus a square. Then sin of hyperbolic at, that is a divided by s square minus a square, and cos of hyperbolic at, that gives s divided by s square minus a square. And next is, that is t to the power n, that should be n factorial over s to the power n plus 1. These are your just like alphabets A, B, C, D. You have to remember all these things. Otherwise, if you do not remember immediately, you can derive using basic definition of Laplace transform. But these things, if you do not know, and these things if you do not know, you cannot make the things easier. But this topic is very comfortable, provided you make all these things comfortable in your memory. That means you have to remember the both derivation, means formulation of all these results, and as well as formulation of all these results, as well as application of all these results. Fine. And then special properties which you are going to discuss as shifting property, that is L of e to the power at, and then f of t. The continuation of this list I am going to write, that is f of s minus a. If you remove this L operator, then you will have to write on the other side as inverse Laplace transform. Then next property, that is t to the power n multiplied to f of t. This is called, first one is shifting property, second one is derivative property, otherwise multiplication by algebraic term. Multiplication by algebraic term is t to the power n, and then f of t is there. The result is minus 1 to the power n. It is dn of fs divided by ds to the power n. This f of s is due to L of ft. That means this f of t gives us fs, and there also you can understand, that is inverse Laplace transform. As and when we require, we will reverse the value. So this is these are the two important properties normally we will apply in under the heading, that is Laplace transform of derivatives. Now I will go for 2-3 simple examples, that means simple applications to make use of all these results with your knowledge, and then I shall go for some partial fractions in this first and second problems themselves, and then I shall discuss some other cases. Okay. Now the question is applications, that means we are coming to the end of all these formulations. Now these formulations are going to be applied to solve the problems. Problems will be as differential equations. Those differential equations will be like physical situations which explain the initial conditions, and as well as different types of symbols. Different types of symbols means ordinary differential equations only, but with initial conditions, as if the first order is given, then one set of initial conditions you will expect, and if second order differential equation is given, only two initial conditions are compulsory, because you can easily make out the integration when you are doing, in order to write the solution of differential equation. In that integration, first order derivatives there, means you will integrate once. As a result, one constant of integration you are going to expect. If the second order differential equation is there, then 2 times you have to integrate. When you integrate 2 times, then you need to write 2 constants of integration, and when you come across a third order derivative, that means third order differential equation, then you need to expect 3 constants of integration. Let me take the first simple example as first example. I call this one right from this example itself as an application problem. What is that? We call it as initial value problems. or application of Laplace transform for differential equations. Remember, differential equations of what type we are going to discuss? Differential equations with constant coefficients and linear differential equations. We are not going to discuss non-linear differential equations in this topic. We are going to discuss only the linear differential equations and constant with constant coefficients. Constant coefficients means a variable, whichever the variables are given as independent variables, they are not going to be multiplied to the derivatives. Simple case, if I take solve y double dash and that is plus y is equal to 0 with y of 0 is equal to 1 and y dash of 0 is equal to 2. This is one simple case taken as application, meaning this differential equation will be represented for some application, meaning then initial conditions are given, that is this is initial condition, and you remember the difference between initial conditions and boundary conditions, because in the engineering problems you need to know very clearly what exactly the meaning of initial, what exactly the meaning of boundary conditions. In any problem we are not going to discuss about boundary problems. In this case we are mainly concerned with ordinary differential equation and derivatives with constant coefficients and initial conditions, but not boundary conditions. These three things you must expect. Okay, that is y 0 equal to 1 and y dash 0 is equal to 1. If you want to write the differential equations so clearly in terms of the derivative symbol, this y double dash and y is equal to 0. Here easily you can make out the problem statement gives y as the dependent variable, because it is clearly appeared, that is in the form of derivative. So this y double dash d square divided by d of what you have to write, d square y, anyway it is to be taken as it is, but denominator you have to take, because in the Laplace transform normally we take this t as the symbol represented for independent variable. Therefore this must be written d square y divided by dt square plus y of t is equal to 0. Then the initial conditions, that is y at t is equal to 0 is equal to y naught, that is equal to 1, and y at t is equal to, sorry, y dash at t is equal to 0, then it is equal to y naught dash, that is equal to 2. This is the details of writing the problem in another form. This is short form, but this is in the detailed form. Yes, this d square y divided by dt square plus y of t is equal to 0 and initial conditions are given. Initial conditions and boundary conditions, that means here initial condition at t is equal to 0, that is at the origin itself, and that is y naught dash is equal, y naught is equal to 1 and y naught dash is equal to 2, means at the single value of this initial condition, independent variable, that is t is equal to 0, two different functional values are explained. That is, with respect to the single independent variable value, different functional values are to be are given, then it is called initial conditions. And not only at t is equal to 0, but at another value of t, say for example t is equal to 1, y at t is equal to 1, then it becomes boundary condition. So more than one value of independent variable when we assign, that becomes the boundary condition. Therefore, initial conditions are written like this, the given initial conditions, then the short form of the notation is this, y double dash plus y equal to 0. Now we have to solve this differential equation, or we call it as, now we call this one as IVP, that is initial value problem. Initial value problem, that is in the short form we call it as IVP, means application of Laplace transform on the differential equations. Fine. What you have to do is, you take this differential equation and then applying Laplace transform on both sides. Laplace transform on both sides takes the meaning, to every term you have to apply Laplace transform. First term is L of y double dash t, you have to write now in the brackets t only, and plus of L of yt is equal to L of 0. Then you have to write the transforms of derivatives we have discussed earlier to this problem, or the corresponding expression you have to substitute. Only the expression for second order derivative you have to replace in this problem and make use of these initial conditions, that is y0 is equal to 1 and y dash 0 is equal to 2. Then the expression takes for this one s square L of yt minus s into L of y0. You have studied in the form of f, and in place of f, wherever f is there, you have to write that f as functional value, but here y as the functional value, y of t, y of 0 minus y dash of 0. Then these three terms are due to application of Laplace for second order derivative. Then this remains as it is, L of yt is equal to, what is the value of L of 0? L of 0 is equal to, either you can derive this value through basic integration of Laplace transform definition, or the first elementary result, the first result also you can apply that L of 0, because L of k, when k is a constant, that is k divided by s, when k itself is equal to 0, that is here in this case L of 0 means this f of t 0 divided by s, that is equal to 0. Otherwise also it is obvious, because we are dealing with the definite integral, when the function under the integral sign is 0, then that value of the integration is also 0. So by that meaning also you can write 0, and here with this meaning also you can write 0. Now what we do, given initial conditions, that is y0 equal to 1 and y dash 0 is equal to 2, in that place we substitute s square L of yt minus s into y0, that is 1, minus of 2, that is y dash 0, and plus of L of yt equal to 0 we have. Then what we do here, in every problem, these are the compulsory steps which you have to follow. Now after this, the next rearrangement, that is s square Lyt and Lyt, these coefficients are common. You can write L of yt here and multiplied by what term? Multiplied by s square here and plus 1 here, and these two terms are not multiplied by L of yt, shift them to the right side, that is equal to minus s becomes plus s, minus 2 becomes plus 2. Then what all that you have to do is solution of differential equation. What do you mean by solution? You have to write y in terms of t, the expression making use of all these initial conditions. Then L of yt is equal to s plus 2 divided by, it is s square plus 1. Now this is still in the form of Laplace transform operator. Then L of yt, that means you have to separate that, then y of t, shift this operator to the right side, that is L inverse. Otherwise, operate L inverse on both sides. In any meaning, that will take like this: yt is equal to L inverse, that should be s plus 2 divided by s square plus 1. This is L inverse. Then to get the final result of as a solution, still as I told you that after understanding the Laplace transform, the outcome of the Laplace transform application is you have to apply a direct Laplace and you have to apply inverse Laplace. Combining these two, you have to put it as last step. What is that last step? L inverse, that is you split this one, s by s square plus 1, one term, plus 2 into L inverse, that is 1 by s square plus 1. Directly you have ready results. L inverse of s divided by s square plus 1 gives us cos of t and plus 2 times L inverse of 1 by this one is, it is sin of t. So this should be your answer. Then y of t is your function. Now you can make use of this result for any interpretation. Then Laplace transform finally as a first application, first case, transform of derivatives. On the right side I have taken it as 0 as a first case. Then this is the solution which is free from derivatives. I would like to stop up to here. Then I shall continue in my next lecture. If there are any questions, now you can ask that, I will answer the questions.